Alright, so we're going to go ahead and continue solving different types of quadratics. These are equations that are quadratic types, which means they don't really look like a normal quadratic would, but we can still solve them by using the same methods that we do to solve a quadratic, like factoring or quadratic formula or taking the square roots. So let's first just look at how we would factor some normal quadratics, and then we'll talk a little bit about how the types differ. So if we just have this as a normal quadratic, then we know we would be able to factor this into x and x. Our factors would be 3 and 2, and I would have a minus 3 and a plus 2. Remember your factoring rules. Your negative back here tells you that these signs are going to be different, okay? And then this negative means that the bigger number, the 3 right here, would have to be negative. Alright, this equation should have a 2 right here. Okay, so now that it does, if we were to factor this, I would still factor it in the same way. Instead of being x and x, though, to make the first term x squared, I would end up making this an x squared and an x squared to make the first term this x to the 4th. Okay? And then my factors for 6 are still going to be 3 and 2. And I'm going to end up having a plus 3 minus 2. Alright, so we did this to show that it really doesn't matter what these are, what the exponents are, or what the variable is. As long as the trinomial is in a quadratic form, we can factor it the same way we would a regular quadratic. So let's look at this last one. Okay. We've got a triangle instead of a variable there. So how would we factor this? We would use a triangle and a triangle instead of an x. Okay, so it would be triangle, triangle. And then our factors on this one would end up having to be 6 and 1, and we would have to do a minus 6 and a plus 1. Okay, so it really doesn't matter what variable or what's right here, as long as we have this quadratic form, okay, where the first variable is squared, the next one is not, and then we've got a number. We can solve it the same way. So let's look at an example. Okay, these are the steps that you're going to go through every time. The first thing that you're going to do, and I'm going to do this I'm going to do these steps as I go through this problem right here. The first thing that you're going to do is always check to see that the first variable is the second one but squared. And so what that means is I'm going to look at not the coefficient but the variable. So this right here, and I'm going to take and make sure that if I take the square root of x, if I square that, then that would give me x, which would be what my first variable is. Okay, so unless this step works and checks out, we can't use this substitution method to solve this kind of equation. Okay, since it does work, I'm going to go ahead to the second step and let u be the middle term. Okay, and so I'm going to let u be the middle term because now I can substitute that u in for that square root of x. So if I just rewrite the middle term, this is what I'll have. 9u. Okay? I just plugged in the u for the square root of x. Okay? Now, I'm going to rewrite this equation in a quadratic form. And so as long as I keep this relationship the same, the second variable is just, if I square it, I get the first one. I'm going to keep that relationship the same and say, okay, if I take u and square it, that's just going to give me u squared. Okay, and then plus 20 stays the same. So now we went from an equation right here that does not look like something we can factor to an equation that looks like something we're used to and that we can factor. So I'm going to go ahead and factor this down just like I normally would. Okay, so I've done steps 1, 2, and 3. I've written it in the form of a normal quadratic, and now I'm factoring. So u and u, the factors would have to be 4 and 5, and then both signs are minus. Alright, so then this is going to end up being u equals 4 and u equals 5. Now, our last step says that we have to substitute u back in and solve for x. Okay, so in our original problem, we were trying to solve for x. And so we still want to solve for x. We're not trying to just solve for u, we're trying to solve for x. So I'm going to substitute the square root of x back in for u. Okay? And then I'm just going to solve that. So in order to solve that, I'm going to have to square both sides. So I'm going to go ahead and square everything. And so then x right here would be 16 and x would be 25. Now, in order for these to both be solutions, I need to make sure that they work out. Okay, so because I know they're going to work, these two solutions are going to work for this quadratic that I found, but sometimes this substitution process will give us some answers that may not work in the original. So I'm going to go ahead and show you how you can check these two answers on your calculator. So go ahead and get your calculator out if you have one. If not, watch what I do. Alright, so what I'm going to do is check my two solutions, and the way that I'm going to do that is by showing you a trick that I think is really handy sometimes. So I'm going to take this answer, okay, this first answer that I want to check, and store it for x. And the way that I do that is I take 16 and then this little STO button right here, so I'm going to store it for my variable x and hit enter, okay? So now what that does is anytime I hit x, it automatically thinks that x is 16. So what I'm going to do is type in my original equation and check to see that whenever I type in 16 for x, or plug 16 back in for x, it's going to give me 0. So all I have to do to check that is type in the original equation. So x minus 9 square root of x plus 20 should equal 0. Okay, and it does, so that works. Alright, I'm going to try my second equation now, or my second solution, 25. So I'm going to do the exact same thing and take 25 and store it for x. And so now the calculator thinks that x is 25. So instead of typing all of that equation in again, I'm just going to hit second enter, which is going to bring up the last thing that I typed. Second enter one more time to bring up the next to last thing I typed. So now that I'm checking 25, it also gives me 0. So I know that both of those solutions are going to work. And so these two numbers are my answer. Alright, let's do another example. Okay, number 2. I'm going to first do the first step, okay? So I'm going to check to make sure that the first variable is just the second one but squared. Alright, so if I take that second variable, x to the 1/3, and I square that, okay, we need to multiply these exponents right there. And so 1/3 times 2 is just going to end up being x to the 2/3. So it is the case on this equation that the middle one, if I take it and square it, gives me the first one. So this is going to be 9u squared plus 24u plus 16 equals 0. Remember, we're going to let u be that middle term, so x to the 1/3. Okay, so I just substituted u in for that 1/3 right there, and then kept the relationship where if I squared the middle term, or squared this second term, then I get this first one but squared. Okay, so if I took this and squared it, I get that. Take this and squared it, I get that. So now I can factor this like a normal quadratic. Alright, and so when I factor this, you might have to test it out a couple of times. You're going to end up getting 3u and 3u, and 4 and 4. Okay, both of the signs right here are plus, so both of these signs have to be plus. And so then u is going to equal a negative 4/3, and it's going to be the same for both of these factors, so I'm just going to write it that one time. Now, I'm going to end up substituting back in right here. Now remember, I don't want to solve for u, I want to solve for x. So I'm going to substitute what I let u be, x to the 1/3, back in. So x to the 1/3 equals negative 4/3. Now, I need to get rid of this exponent, okay? So the way that I'm going to go about doing that, remember, if you go back to your Algebra 2, let's review right quick. Alright, so if I have a rational exponent, all that is just an exponent that is a fraction. Okay, and so when I have something like x to the 1/2, what that really means is the square root of x. So a rational exponent is the same as a radical. So when I've got x to the 1/3, what that really means, instead of being the square root of x, it's just the cube root of x. So what I've really got right here, and I'm going to rewrite this, is the cube root of x equals -4/3. Alright, so now, the way that I'm going to get rid of the cube root is to take it and cube both sides. Okay, so when I cube both sides, that's going to leave me with x equals, and then -4 cubed is going to be a -64, and 3 cubed would be 27. So -64 over 27 is my answer. Now remember, we have to check our solution, so I'm going to plug -64, add that. So -64 over 27 is what I'm going to store for x. And then I'm going to type in my original equation. So my original equation is going to be 9. And then the x is raised to the, and I'm going to type this in parentheses, 2/3. So 9x raised to the 2/3 plus 24x raised to the 1/3. And then plus 16. Now if my answer is an actual solution and it works, it should give me 0. And it does. So this is a solution that works, so this is my final answer. Okay, number 3. This one looks pretty complicated, but it's really not too bad. So I'm going to check to make sure. Here's my middle variable, or what we're calling a variable. So x over x minus 1. If I take that and square it, I do end up with this whole thing just squared in the front. Okay, so our method is going to work, and so I'm going to let u be the middle term. So x over x minus 1. So then when I substitute that in, I'm going to have 10u, and remember, we've got to keep that relationship. This gives me this when I square it. So u squared needs to go there. The 3 goes out front. You don't square the numbers, just what we're considering the variable. And so then I'm going to go ahead and subtract this 8 over to get it to look like something that will factor. So now when I go ahead and try to factor this, my factors have to be 3u and u. And then if you try it out, you're going to end up with 2 and 4 here. The 3 and the 4 will give you 12, 2 and u give you 2, so those can combine to give you 10. So my signs need to be a -4 and a +2. So then u is going to equal a -2/3 from the first factor, and u is going to equal 4 from the second. Now, we don't want to solve for u. We've got to plug back in what we let u be. So I'm going to plug this fraction back in right here. So this is going to be x over x minus 1 equals a -2/3, and x over x minus 1 equals a 4. And I'm going to stick that 4 over 1. Now, the easiest way to solve this, because you have an equal between there, and you need to keep this in mind, so we'll review this right quick. When you multiply fractions, so that is when you do not have an equal sign in between two fractions. So if you were to multiply 1/2 times 1/3, you multiply straight across. So 1 times 1 would be 1, and 2 times 3 would be 6. Now, when you have an equal sign in between there, it changes it. So now it's an equation. So if you have an equation that looks like this, let's say we had 1/2 equals x over 3. A lot of people get this confused with multiplying fractions. Here we're just going to multiply by cross multiplication. Okay, you cannot do that when it's two regular fractions, but for our examples right here, we're going to cross multiply, and you would do the same thing for a problem like that. So we're going to go ahead and solve by cross multiplying, and remember, the reason that we can do that is because there's an equal between there. So we're going to have 3x equals -2 times x minus 1, and I'm going to go ahead and solve this before I go on to the next one. So 3x is going to equal negative 2x plus 2. If I add the 2x over, I'll have 5x, so 5x equals 2. And so then x is going to equal 2/5. Alright, from the next one, when I cross multiply, 1 times x is just going to give me x, and then I'll have 4 times x minus 1. When I distribute, that'll be 4x minus 4. And I'm going to combine like terms, so I'm going to subtract the 4x over. So that'll give me a negative 3x equals a negative 4. And so then x here, when I divide by 3, would give me a positive. Negative divided by negative is a positive 4/3. Now, I have to check both of these solutions. This one is one where you're going to have to be real careful plugging this in. Okay, and we know that if we want it to work, or if our solutions work, it's going to give us 8. So the first thing I'm going to do is plug in my answer. So I'm going to say 2/5 store for x. Alright, and so I'm storing that for x, and I'm going to type in my original equation. So I'm going to type in 3 parentheses. X divided by, now that entire bottom piece, x minus 1, has to be grouped in parentheses together so it all stays on the bottom. And so I've opened 2 parentheses here, so now I've got to close 2 parentheses there, and that is squared. And now minus 10, same thing, x divided by, open the parentheses, close them twice. You open them twice, you close them twice. And so now, if this 0.4 or 2/5 works, my solution or my answer when I hit enter should be 8. Okay, and it is. So the first one works. Let's try 4/3. Try 4/3, store as x. Remember, you're not going to type this whole thing in again. You're just going to hit second enter. And then that will also give you 8. So these two solutions that we found will work. Alright, number 4. If I were going to try one on my own, I would try this one. So if you would like to, go ahead and pause and try this one on your own, and you can look at it. This is a little bit of a challenge problem. So I'm going to go ahead and do it. I'm going to let u be the square root of x, because if I take this and square it, I get x. So then I've got u squared minus u minus 11 equals 0. Most of you could probably get that far. Here's where the challenge comes in. If you try to factor this like we've been factoring it, that's where it gets a little bit challenging, because you can't factor this. So we've got to use one of the other methods that we talked about when we solved quadratics to solve this. So the way that I'm going to go about solving this is I can't take the square root, because I've got this middle term here. What I'm going to do is use the quadratic formula. So I'm going to let 1 be a, negative 1 be b, and negative 11 be c. So when I plug these into the quadratic formula, I'm going to have x equals a negative b, so negative and then a negative 1 plus or minus the square root of negative 1 squared minus 4 times a times c, all over 2 times 1. So I'm going to go ahead and simplify. So x equals 1 plus or minus the square root of, underneath the radical, it's going to end up giving you a 1 minus, well, this negative and this negative are going to combine to make a positive, so this is going to be 4 times 1 times 11 would be 44. So I'm going to end up with a positive 45 under there, divided by 2. Now, I can go ahead and simplify this radical right here. So I'm going to go ahead and do that. This is going to be able to be broken up into 9 and 5. So from the 9, I can bring out a 3, and so my simplified answer is going to be 1 plus or minus 3 square root of 5 over 2. Now, that really means I've got two solutions. I've got 1 plus 3 square root of 5 over 2, and I've got 1 minus 3 square root of 5 over 2. Now, I actually shouldn't have written this with an x right here because we weren't solving for x at that point. We were solving for u. So I'm going to go ahead and erase that and write a u there. So we were solving for u. So u equals these two solutions right here. Now, u wasn't our actual, our variable that we were trying to solve for. We were trying to solve for x. So what I've got to do is set both of these solutions that we found equal to the square root of x. So I'm going to say the square root of x equals 1 plus 3 square root of 5 over 2. The square root of x equals 1 minus 3 square root of 5 over 2. Okay, so to find these solutions, I'm going to have to square both sides. So square both sides, square, square. Alright, to find an answer for this, what I'm going to do is go ahead and just plug that into the calculator and get a decimal to find what this is squared. So when I do that, I'm going to type it in like this. I've got to make sure that in order to keep the top, okay, the numerator together, I've got to put parentheses around this and then square the whole thing. So this is how I'm going to type it in. So, parentheses, 1 plus 3 square root of 5, okay, so there's my top part in parentheses. I had to close the square root, okay, and so then I'm going to go ahead and go back actually and insert a parentheses around this whole thing because I'm going to have to put the top over the bottom, and that bottom piece of it was 2. And so now, this is what I've got. I opened 1, 2, 3 parentheses. So I closed 1, 2, 3 parentheses. And I want to square that answer. So that answer is 14.854. Now, on my paper, I'm going to round that and write x equals 14.854. But I need to check this answer and make sure that it works. Since it's already in my calculator right here, I'm going to store it for x. Okay? And so now let's go ahead and check to make sure that this is a solution that's going to work. I'm going to type in my original equation and then subtract 11. It should give me, if it works, 0. So it does. So that is a solution. The 14.854 works. Now I'm going to do the same thing with this side over here. I'm going to square this, store it for x, and see if it works. So let's go ahead and square this. Now, I noticed that this is the exact same answer. This is the exact same answer as this one, except for this middle sign. So what I'm going to do is not type in that entire thing again. I'm going to make it easier on myself and go back up here and just change this sign to a minus instead of a plus. And so now there's my answer. So I'm going to take this answer and store it for x. And then, again, make it easier on myself and not type in my entire equation again, but hit second enter until it comes back on the screen, and then try that. Now, this does not give me 0, so 8.146, if I round that, x equals 8.146 is not going to be a solution, so that one is not going to work since it didn't give us 0 when we plugged that back in. Okay, last example. Okay, so we've got negative exponents in this one. We're going to do it exactly the same way that we would do a normal problem. So I'm going to check to make sure that when I take this and square it, I get the first term. So x to the negative 1, when I square it, I just multiply the exponents and it does give me x to the negative 2, so we can use this method. So I'm going to say this is u squared minus u minus 20 equals 0. Okay, so factor. My factors are going to end up being u and u, 4 and 5. It's got to be minus 5 plus 4. And so when I solve, u equals negative 4 and positive 5. So I'm going to plug back in what I had let u be. We let u be x to the negative 1. So I'm going to plug back in x to the negative 1 and solve. And the way that we're going to solve this, anytime you have an x to a negative power, to get rid of the negative power, we just use one of our exponent properties, which is just to drop that to the bottom, and the exponent will become positive. And I'm going to pause this for just a second because my phone's ringing. Okay, so we have dropped the x to the negative 1 to the bottom to get rid of the negative exponent. And I'm going to put both of these numbers over 1. And now it's the same kind of problem that we had on example 3, where we just cross multiply to solve. So that's what I'm going to do right here, cross multiply to solve. And so for the first one, I'm going to end up with 1 times 1, which is 1, and negative 4 times x, which is a negative 4x. 1 times 1 is 1, and then 5 times x is just 5x. So our first equation is going to give us a negative 1/4, and our second equation is going to give us a positive 1/5. Okay, so now I'm going to check both of those solutions. So all we're going to have to do is plug in negative 1/4 and store it for x. So I'm going to take negative 1/4, store it for x, and type in my original equation. So my original equation is x raised to the negative 2 minus x raised to the negative 1, and then minus 20, and it should give us 0. Okay, it does. I'm going to take and do the same thing with our second answer. Try 1/5, so 1/5 store as x, and I'm going to hit second enter, so I don't have to type it all in again, and it gives us 0 as well. So both of these two solutions are our answer, and they both work.